Okay. Did everybody get the notes in there? And everybody's got 73.5 notes. Everybody good on that? Okay. Guys, you're going to watch Chromebooks probably in decimals this morning, so if you want to get decimals.com loaded up, that might be a good thing here first. Pretty important stuff today. Now, I'm going to guess that you've been exposed to this a little bit before, but we're going to hammer it again today. It's very important. It's not going to go away in 9th grade. It's not going to go away in 10th grade. It's not going to go away in 11th grade. It's not going to go away in 12th grade. When you guys decide to go to college and have to take a math class, guess what?
It's not going to go away.
It's not going to go away. All right? Not going to go away. So, at the top of this section, 3.5, I want you to write down that this is important stuff. So these notes are very important. All right? And just making sure we understand what it is we're discussing. Guys, the last section, what was the name of the form AX plus BY equals C? What form did we call that last section? No one, you remember? It's kind of like a function notation that we can express that way, but there was another name for the form AX plus BY equals C. Somebody said it. Mason, was that you that said it? The form? I like the word phrase function form, but specifically, what was the last section called, guys? If you're not sure, take a look. Everything was linear, I agree. Start with an S. Standard form, right? Standard form. All right. Well, today what we're looking at is how we describe the graph of the equation mx plus b, which is considered this right here. We're talking about a totally different form of a line today again, calling it slope-intercept form. This is very easy compared to standard form, I think. All right. We'll take a look at what this means here in a second, but our goal today is to find the slope of a line. And you've really already done that. You guys remember when we were looking at changes like in a table? If on the left column it went up by 2 each time, the right column might go up by 6 each time you went up by 2. That's going to be a form of a slope, so we've kind of done that already. We're going to slope-intercept form of linear equations. And we're also going to use those slopes and y-intercepts to solve some real-life problems. So, what's the name of the form we're discussing today? What's the name of the form we're going to discuss today?
Slope-intercept form.
Slope-intercept form. Thank you, Mason. All right. Couple of vocab terms right here. First one, slope-intercept form. So it's a form of a line where y equals mx plus b. What does it say m is, you guys? What's it say m is right here? What's it say m is? M is the slope, and b is going to be the b will be the y-intercept. That's important stuff. So I'm going to put an example in here. Which variable is all alone, by the way? Y will always be alone in slope-intercept form. Okay. So if I write y equals maybe, I don't know, 2x minus 6 right here. Oops, come on. Yeah. If I write 2x minus 6 like that. Guys, what letter's right next to x? 2 is, right? So, questions I'm going to start asking are going to be the following. What's the slope of this right here? Well, the slope is going to be, the slope in this example will be, and I'm going to write it like this. Slope will be 2. Okay? Slope's going to be 2 because that's right next to x. The b value, what's the b value, or what's the b number out here on the end? -6. So what's that mean about the y-intercept, guys? Well, it means the y-intercept is going to be -6. Now, guys, what the heck is slope? Slope is defined as a what over what, guys? Rise over run. Remember how we talked about change in y over change in x to determine if the table was linear or not? You guys remember talking about that? That's all slope is. It's a rise over run. Now, a rise over a run is typically a fraction. So my slope in this example right here, if I had to graph it, I would rise 2 units. What's 2 look like in fraction form, guys? 2 over 1. Okay, so keep that in mind. If you have a whole number slope, you always have to put it over 1. This is going to help you graph that. Okay. And we'll show you what that means here in a second. And then the y-intercept, b equals -6. This y-intercept of b equals -6, that's kind of like the point that you start. The y-intercept is going to be a point when you graph these that you always start at. So the y-intercept is always going to be your starting point for the graph. Let's call it starting PT for point of a graph. And I'll show you what that looks like here in a second. But the y-intercept is always going to be where you're going to start. You're going to always start from the y-intercept. Everybody have decimals open here? Okay, first things first. Let's talk real quickly. See if we can't visualize what's going on here. Identifying slope and intercepts. Now, first of all, anytime you're in slope-intercept form, which variable is always alone? Y is always alone right here. Is y alone in all these right here? Okay. The slope will be right next to the x. The intercept will always be the b value. Okay. I'm going to jump into decimals quickly, so you might want to do the same. Where are we? Google, good morning. You're awake. Decimals, how beautiful it is. Okay, do me a favor, guys. What was the first equation there that we're looking at in that table for example 1? What's the first equation in there? Y. Let me type this in. Y equals what? 2x minus 3. So like so, right? All agree? Okay, let me get this keyboard out of here. Next thing I like about decimals is stuff like this. First of all, what's the y-intercept? What's the same the y-intercept is down there? 0, -3. Does that -3 match this -3 up here in the equation?
Yes.
Just looking at the equation, we should be able to know what the y-intercept is, -3, right? Now, how about the slope of this line? Or in other words, the rise over the run. I'm going to show you something here quickly, so give me a second. According to this, what's the slope got to be? It has to be 2. So here's what's going on. I'm going to do this. First of all, the 2 points that are recognized are here and here. You guys agree with that? Okay, you don't need to write this down, but just watch what I do. If I leave from here, and oh, that's kind of a bad example. I'm going to go from here all the way up to here, and I'll show you why I'm going this way. All right, let me fix this here quickly. Oops, that broke. Let me fix it. Okay, let me draw this again quickly. You guys agree that one point on the line is right here at the intercept, right? If I would follow this up enough, do you agree that maybe this is another point right here that we know what the graph passes through? Looks like to me right 2 and up. This would actually be a 1, wouldn't it? Here in the middle. Okay, watch this quickly. I'm going to draw a line here. What ends up happening is the following, guys. When you have something like this, you have a rise over a run. Okay, in this example right here, I'm going from -3 up to +1. So -3 to -2 is 1, -1 is another, to 0 to 1. There's a change of 4 units right here, kids. What's my run distance to the right? 2. If slope's defined as a rise value over a run value, what's 4 divided by 2 equal? 2. Doesn't that match my slope value right here? Okay. Is that a +2 or -2, by the way? +2. We'll talk about what those look like here in a second. But coming back to your graph, or I'm sorry, your notes right here. The description was, did we get a line out of this when we graphed it, guys? We did. What did we say the slope was in this example? 2. How about the y-intercept? -3. Okay. So without even graphing, let's run through the rest of this on this table right here, guys. First of all, if the first one was a line and these all look like their slope-intercept form, what's the description for all of those examples going to be? If we have y as a function of x and x to the first power, they're all going to be lines. So fill that in right here. line here, line here, line here. Okay. So I want some people to help me out with here on that number 2 example there. Y equals negative 2/5 x plus 6. What's the slope? Negative 2 over 5. Now, if you ever get a negative slope, I'm going to tell you guys, put the negative with the numerator this time. Okay? Put the negative with the numerator right here. So call it negative 2 over 5 like this, negative 2/5. And I'll show you the y here in a second. How about the y-intercept? 6. Very good. All right, the next example. Raise your hand, please. Careful on the next one. Y equals negative x plus 3. How about a slope there, Tori? Negative 1. And how about a y-intercept, everybody? Positive 3. Okay. Even though negative 1 is not listed there, the implication is negative 1 x. If I was doing rise over a run in fraction form, negative 1 would be the same as what as a fraction? How would you write negative 1 as a fraction? What is it, Noah? Negative 1 over 1. Good. Okay. Last one now. What's the slope on this last one? 1. How about my intercept? Negative 2. Okay. So if I say, hey, here's some examples of lines in slope-intercept form. Can you identify slope and intercept for me? Pretty easy, isn't it? Pretty easy? All right. Well, let's jump ahead here. Any questions so far? All right. Page 2.
I have a question
Yeah.
about something. Okay, real quick. Last night I was working on my math assignment and the live tutor thing popped up, and I clicked on it. It was way helpful. Like I liked it, but I only got the answer wrong once. But it just popped up. So like, it's not based on how much you did it wrong. It just pops up randomly.
Good. Yes. I don't know.
Can you get it to pop up? Because like sometimes like there was one later on, and like I was wishing it popped up.
Yeah.
But it was.
So like what happened?
Well, like the first one, I just guessed it wrong once, or like I got the wrong answer, and then it just popped up live tutor. So I clicked on it, and then like 3 later, I wanted help on it, and like I could have got it wrong like 5, 6 times before it popped up.
Really? Weird. Maybe like specific problems are available for it.
Yeah.
I don't know.
Yeah.
So, but it helped you?
Yeah.
So if that comes
She was
up.
way nice.
So it was a real person?
Yeah, her name was Rebecca.
Rebecca.
Yeah.
You didn't tell her what kind of tool that was, did you?
No.
Oh, okay.
No. She's like, she like helped you, and she's like, there you
So
go.
did you have like a face-to-face chat or what?
No.
No.
It was like, you know when you talk to stores online, you're.
So you're like just like in a chat?
Yeah, it was on the side.
Well, cool. That's awesome.
Yeah.
What problem was it?
It was way easy. I overthought. Well, like she said, you know those ones where you wonder why it has to be marked in that certain one. Like it was like graph x equals 4,
Yeah.
but I tried to do it in a certain way, but it had to be over a certain number, and I asked why, and she said, to be honest, I don't know.
She's honest.
So I was like, okay.
Well, that's cool. I'm glad to know that. Thanks for sharing that. I'll share that with the rest of the classes today. That's cool. If that ever happens to somebody in a class, somebody bring that up and show me. If you ever get time in class while you're working and Rebecca shows up, bring that up, you know. All right, I want to see that. Okay. All right, guys. So what I want to do here is this. We want to just make sure we can look at graphs and find the slopes of a line. What I want to do here first of all is this. In the example that we looked at on decimals right here, we said the graph was a positive 2, right? So the thing you need to understand is this. Kind of want to compare the differences of these two graphs right here and see what we can come up with for a slope. So what I like to do, guys, is this. When I'm finding a slope, I like to draw my rise and my run values in. So I always work better when I'm left to right. So I'm going to pick the far left point here. I'll pick the far left point, and I'm going to go ahead and, that's kind of blurry, isn't it? You guys, are you able to read the numbers on yours rather easily? Yes or no? Okay, I'm going to just look at this little slope right here. Here, guys, I'm going from point to point. I'm going to do a rise over a run from the first one to the second point. Okay? So find the slope here. What's the rate of change of that line? How much does that line change? How much does that line go up or down for every 1 unit I progress to the right? Well, guys, if I chose 0, 2, and 3, 5 as my points, what's my rise if you count this here? Help me out. What's the rise? 3. What's the run? So how about a slope? What's 3 divided by 3? Not me, but 3 divided by 2. Rise over a run. what are you going to have for slope?
1.
1. Okay. Now this would have worked well this way if I'd have gone this way. What if I would have drawn it like this? What if I would have gone up a certain number of units this way and then a certain number of units this way? What's the rise in if I go by the red L, rise over run? How many units did I rise? How many units did I rise? 4. How many did I run? Careful. 4, didn't I? So I could have used 4 over 4. In either case, 3 over 3, 4 over 4, they both divide out to be what value? 1, right? They divide out to be 1. So in this example right here, I'm going to say the slope is 3 over 3, right, guys? But in simplest form, you know those problems at the end of your assignment said simplify these fractions? Yeah, that's why they wanted you to do it. They wanted you to get ready to start simplifying for slope. So 3 over 3, what's it equal?
1.
Now, guys, is that a positive 1 or negative 1?
Positive 1.
If a line moving left to right looks like it's uphill, is positive in slope, then how about this line as I move from left to right going downhill? What's that? What kind of slope do you think that's going to have? So let's take a look here quickly. I'm going to go rise over run. Again, I like to work left to right. The 2 points that are identified are here and here. So I'm going to go ahead and I'm just going to draw in my rise and my run. So here's my rise and da-da-dee is the run. Okay. Help me with my rise, guys. Help me with my rise, guys. You wise guys, help me with my rise, guys. All right. 1, 2, 3, 4, 5, 6. I count 6. You guys agree with that change?
I do.
Although what kind of a 6 since I'm moving down?
-6.
So the rise is a -6. Help me from the run to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. I get 9 down here. 9 down here. Okay. So the slope is going to be a rise, -6 over a run of what? 9. Okay, so in this example right here, slope is going to equal -6 over 9. Let's put that in simplest form. What would the 6 over 9 reduce to, kids? I heard it somewhere. It's -2/3. Okay, so the slope in simplest form here, -2 over 3. Okay. All right. So that's pretty easy. If I give you a graph and say find the slope, you're basically counting and then putting your rise count over your run count and then simplifying a fraction, aren't you? You understand the difference between a graph which is uphill and downhill? In the first example, slope was positive, uphill. Second example, slope would be negative, going downhill here. Okay? Good, Candace? All right. So, guys, what I want to do then is this. I want to start finding a slope from the table, but I don't necessarily want to graph this. All right? Pretty easy to do, guys. Nice formula for slope. All right? This is kind of a goofy formula, but follow me on this. First of all, m represents the value of a slope in slope-intercept form. Here's your formula. Okay? Basically, that says it's a change in y over change in x, but we denote it differently. We say m is equal to y2 minus y1 over x2 minus x1. Okay, so the implication is here I have to pick out 2 points. Okay? I have to pick out 2 points, and I don't care which points you pick. There's 4 different points up there. What points do you want to pick out? Let's pick out one of the points with a negative in it. How about the first one? What is the first point, guys? -3, comma, -1. Okay, so I'm going to call this I'm going to pick this point right here. The -3 is going to be like the first x value we chose. The -1 is going to be like the second x value you chose here. Okay? I'm sorry, I've got that mistaken. The -1 is like your first y value chose. Okay? So that's the first x comma y pair that we picked out. Now, let's pick maybe the last point. Again, because it doesn't matter. How many of these points do you have to choose? 2. Makes no difference. I'm going to choose this right here. Over here, I'm going to choose the 3, 11. This means that this is my second point chosen. So my x2 value is 3, and my y2 value is 11. Okay. So my first xy and my second xy, that's all we do. So to find the slope between these 2 points right here, guys, it's pretty simple. It's pretty simple. You simply plug in y2 minus y1. So in this example right here, what is y2? What's the second y value that we chose? What would you plug in for y2? 11. And then bring the minus sign down. How about your y1 value? What do we have there? 11 minus negative 1. I'll put that negative 1 in parentheses, okay? So I filled in the y2 and the y1. Now on the bottom it says find your change in x, or x2 minus x1. Well, here we go. 3 minus what? 3 minus what? Careful, 3 minus what? Negative 3, change in x's. All right, so a little bit of arithmetic here. When you subtract a negative, that's really what operation? Addition. So what's really 11 plus 1 up top? 12 over, what's 3 plus 3? What's 12 divided by 6 equal then, right? It's 12 divided by 6. 2. So my slope is 2. Okay, so what this means is this. What this means is this. For every change in y or change in x, it means that y will go up 2 units for every 1 unit that x changes right there. That's what that means. That's what that means. So the formula is pretty important for you guys right here, finding slope. And check it. The thing I like about decimals is this. What was the first point we input? Was it negative 3? Does that sound right? Negative 3, negative 1? And there's that point. And then the second point was 311, wasn't it? There's my 2 points. Watch this right here. My rise distance is 12. My run distance is, I count 1, 2, 3, 4, 5, 6. 12 over 6 again, right? What's 12 divided by 6? 2. Okay. So keep that in mind. I meant for every 2 units I went up, I went over 1. Every 2 units I went up, I went over 1. Every 2 units up, over 1. Every 2 units up, over 1. Every 2 up, over 1. Every 2 up, over 1. Oh my gosh. See the stair stepping going on there to get to that other point? All right. Constant rate of change. It increases at the same rate. If you ever hear the word rate anymore from now on, if you ever hear rate or miles per hour or dollars per hour or dollars per pound, that is always some kind of a rate of change which we consider to be our slope. All right, so very good. Questions about that formula then? Double check and make sure you've got that written down exactly as I do. Just a matter of plugging in and figuring stuff out. Okay? Let's look at another one. Let's look at another one. Somebody choose a point for me up here. First point. Negative 4, negative 2. So here's my x1. Here's my y1. And then from that other one, choose another point up there. I don't care which one you choose.
8, negative 2.
8, negative 2. All right, we'll take that one. That can be my x2 and my y2. I want to talk about what's going on here quickly. First of all, what do you notice about all the y values this time? They're all the same, aren't they? Okay. So let's do my slope by formula. y2, what's the y2 value, gang? Minus my y1. All over x2, which is 8 minus x1, negative 4. Guys, up top, this is really negative 2 plus 2, so what are you going to have up top? Careful. 0, right? How about on the bottom? What are you going to get there? 12. I'm going to type something in on decimals real quickly. What is 0 divided by 12, guys? 0. All right. I'm going to punch this in real quickly. I'm going to show you what the graph would look like here for those points that form a line. Here's the graph you get right here in your points. What was your first point, guys? What was your first point? Wasn't it -4, -2? Up 4, down 2. Is that a point right there? Wasn't 0, -2 a point? What were all the y values again? They were all the same, right? What's the equation for this horizontal line then? Which axis does it cross? The y-axis at what value? Y-axis at what value? -2. Now guys, this is just going to form a horizontal line. And when you form a horizontal line like we've indicated right here, it said the slope is 0 divided by 12, means the slope is 0. So for this particular example, you might want to write down, this is a horizontal line. This is a horizontal line. And anytime you have a horizontal line, what's the slope value going to be? Slope is 0. Anytime you have a horizontal line, the slope will always be 0 because the y values did not change. Did not change. All right, no problem. I'm going to choose these 2 points right here for the next table and show you what the heck is even going on here. Guys, in this next example, instead of all the y's staying the same, what's staying the same? All the x's are staying the same. So if the y stayed the same to produce a horizontal line, the x's staying the same would probably imply what kind of a line? Vertical. Well, let's check this out about a slope. Let's check this out about a slope. First of all, let's do our 2 points. I've got an x1, y1. I've got an x2, y2. So help me out with my slope. What is y2 first? It's your y2 value. 4 minus your y1. -1, right? And then x2 minus x1 would be 4 minus 4, wouldn't it? So this becomes the following, 5 divided by 0. Ooh boy. Up here we had 0 in the numerator and we were able to get a value. But what don't you ever want in a denominator? 0. What happened here? 0 is in a denominator. Anytime you have 0 in a denominator, well, what is 5 divided by 0? Nope. You say division by 0 is, you can't do it. Okay? It's undefined. If I say divide something 0 times, divide something 0 times. Divide something by 0, or divide something 0 times. Is that working out for us at all? When I say divide it up 0 times, do you have to divide it at all? You don't, do you? Okay, so it's undefined. You can't do it. So in this case right here, we say the slope is undefined. Okay? And the graph of that was going to be a vertical line, an up and down line. So that slope would be undefined. Okay? Slope would be undefined. This is some kind of a vertical line. So the thing you need to remember is this. If you have a horizontal line, left to right, what was the slope in the previous example? 0. Okay? 0. That floor that you walk on out there, how about the slope? Now it's horizontal. Should be what? 0. Okay? How about the slope of the wall if this building is built square? How many units do you rise for every run? Well, there is no run. So if you can't run, there's no slope. Alright? The wall slope would be undefined. Okay? Guys, make sense of this? Give me some sort of science you're alive right now? Make sense? Okay. Alright, example 4 here. Looking at graphing equations. So this is pretty easy. Question?
No.
Okay. Alright, so let's just talk this out. How do you graph stuff in slope-intercept form? Now again, if you're not sure your graph is correct, jump into decimals. Alright? Here's the guidelines for graphing. It's the first step always. Step 1, always. Plot your y y-intercept every time. So in this equation right here, y equals 3/4 x minus 2. What is the y-intercept? What value is the y-intercept? -2, right? It's -2. It's the b value, -2. So in this case, I'm going to write down, hey, y-intercept's -2. So I'm going to go ahead and plot that. So I'm going to say, hey, on the y-axis, come down here to -2 and plot that. Everybody agree? Now, once you've done that, step 2. Oops, didn't want that. Step 2. You want to do your slope. You're not leaving from the origin anymore, but you're going to leave from the, where am I starting at, guys? What do we call that point in red? We're leaving from the y-intercept. That's your new starting point. Okay? So we're going to do our slope from the y-intercept. What is my slope, guys, in this function? What is my slope? Isn't it 3 over 4? So from here, from the y-intercept, I'm going to rise 3 and run 4. This better be an uphill graph or downhill graph, by the way. Why? Slope's positive, better be uphill. So I'm going to go ahead and do this here. On my graph, I'm going to move up 3 units. So I'm going to go up 1, 2, 3, right? 1, 2, 3, 4. And there's a second point. And once you have those 2 points plotted, simply a matter of just making sure you've got it graphed correctly. So with a straight edge, if you have like a lunch ticket or something, this is what your graph is going to look like. How did I do? You guys okay with that? Let's make it a quick 2 line. There it is. There it is. Just like the other day, couldn't I go through that and find problems within the context of this right here? Well, it'd be pretty easy to do. Down 3 over 4. I don't like the way that's graphed anyway. I like that better. Okay. You guys okay with it? All right, so let's do this. Again, start where, guys? Where do you always start from? Start the y-intercept, step 2, do your rise over your run. Now, next one's kind of interesting because this only works if which variable is all alone all the time, guys? The y. As long as the y is all alone on one side of the equation or you're in function form, you can get away with it. There's y all alone in the next example.
Yep. Oh no.
It's dating 2x right now, isn't it? Isn't y dating 2x on that side right now? Who's single right now in this? 6. Okay? You know what? The number 6 might be looking kind of good to 2x right now. 2x might not like y anymore. So y might become this person that's all alone. We've talked about getting y alone before, haven't we? What do I have to move out of here to get y alone first?
2x.
I'm going to add 2x, subtract 2x.
You're
I'm going
going to subtract it.
to subtract 2x from both sides. Let's do that. So what I'm getting at here in this example is the following, guys. If y isn't alone, you might need to rewrite an equation before you can even proceed on this. Now, guys, that is standard form, isn't it? That is standard form from last section. You guys agree? I just want to kind of talk this out quickly. What would the x-intercept have been? 6 divided by 2. What would that have been? 6 divided by 2 is what value? So I know my graph's going to still hit the x-intercept of 3 there. What would the y-intercept have been from the last section? 6 divided by what? 1, which would be, okay, we could have gotten away graphing it that way like we did in the last section, as long as you can recognize its standard form. Well, let's see if that graph matches this after we rewrite this in the slope-intercept form. You said subtract 2x from both sides, so I'm going to be left with y on the left, and on the right you're going to have negative 2x plus 6. Okay? So once I've identified that y is alone in the form negative 2x plus 6, what's your slope again? What's the slope? After I've rewritten it right here, what's the slope? Negative 2. And in fraction form, negative 2 over 1. What's the y-intercept in this? 6. Okay, watch this right here, guys. When I graph, what do you guys just say the y-intercept was? 6. Oh my gosh, doesn't that match what we already had up here? Doesn't that match what we already had up here? And now what's your slope? So come down 2 units and right 1. Down 2, right 1. Okay. I'm going to go ahead and graph this now. If I've done this correctly, wow, does that go through an x-intercept of 3 right here like we thought it would? It does, doesn't it? Okay. Which form is easier, standard or slope-intercept form? Or are they just both easy? I think they're both pretty easy. I think slope-intercept form is probably easier of the two. So in that example right there, kids, our job is, well, if y isn't alone, get it alone. And once y is alone, identify your slope, identify your intercept, plot your intercept, do your slope, draw your line. Okay? That's how you operate that. Questions about that at all? Let's go to the next page. Everybody have this down? Anybody need more time? Let me know. So good. Gosh, that's good. All right. Next page. Is this in standard form or slope-intercept form as it sits? As it sits. This equation, example 5. Is it slope-intercept form or standard form? Careful. Standard form. Is y all alone? No. Can I make y alone here? What would the rewrite look if I wanted y to be all alone in this? Subtract an x from both sides. So y would equal, on the right side, negative x. Furthermore, negative 1x, right? And then the 2 was negative, so minus 2. Okay? You guys take a second and graph that. I'm going to have a volunteer come up and do this for me. Who's brave enough to come up and graph this for me? All right, Kayla, you're up, kid. I'm going to go hang out at your desk and draw it on your graph, okay? Or are you ahead of me there, too? Kayla, I don't understand this. Talk me through it, all right?
Okay. The y-intercept is negative 2.
Everybody agree negative 2 is the intercept? I might write down off to the side, b equals negative 2. Be careful on your slope, kiddo. Go ahead.
And then I'm guessing here, but the slope will be negative 1 over 1.
Okay.
And so you go down 1 until the right 1. And then
So what? Say that again one more time. Down 1 and left 1. You said.
yeah, to the left.
Can I ask a question real quickly, Kayla?
Yeah.
All right. Before you even form that line of those 2 points, will that give you an uphill graph or a downhill graph? Look at it again. The 2 points you've got plotted.
Oh,
Will that be an uphill graph or downhill graph?
uphill.
If you have an uphill graph, is the implication positive slope or negative slope? So what kind of a slope do we really want? So when you come down 1, you then say over 1, I want you to go to the right. Okay? Make your rise go either up or down, but make your run always go to the right. Alright? So I'm from, hit the undo button up there. Can you see it? Yep. And instead of going there, you go down 1 and right 1. And think about it. Your rise, negative 1 divided by your run, positive 1. Like negative 1 divided by positive 1. Be negative 1 unless we have a problem. The way you went down 1 negatively, and then to the left. Well, left is also negative. So the way you had it was like negative 1 over negative 1, which is really what kind of a value. Okay with that? Okay, very good. All right, keep rolling.
And then
have fun sitting here. Yeah, he was straightened out. Why don't you like that? You should.
Yeah.
I mean, I agree with what Kelly has there. I like it a lot. Very good.
I'm sorry.
This must be your pencil, huh? All right, very good. Thank you. By the way, what would the x-intercept have turned out to be in this case then? That's what the question asks. Once you've done it, the x-intercept graphing, -2. And even in standard form, I could have taken -2 divided by 1, which would have still been at -2. Okay? Guys, I don't care which way you graph. Standard form, slope-intercept form. Either way, they both form the same line. Okay? Okay, very good. Well, let's look at example 6. This is a pretty important problem. Pretty important problem. This is graphing from a verbal description. I like this problem a lot. All right, I want to go back to this idea here quickly. I told you f of x is always equal to a what, guys? Everybody agree with that? So in here right here, if I had f of 1 equals 7, this implied that when my input of x was 1, my output was what? 7. This is like an ordered pair of a point, 1, 7. So recall that from section 3.2. Okay? This is going to help you remember everything there. Right? If I say f of x is really equal to a y, and then give you an example, f of 1 is equal to 7, that's like saying the point you're talking about is 1, 7. So, in example 6, graphing from a verbal description, it says, we have a linear function g, which models a relationship in which the dependent variable increases 2 units for every 3 units the independent variable increases. There's a lot of wordiness there. We've been talking about slopes and y-intercepts. They say an increase of 2 for every 3 units of independent. I don't like the wording there. Let's see, an increase of 2, is that going to be an up or a down? Increase of 2 would be an up 2, right? This mess right here where it says increases 2 when the independent variable increases, this is just simply saying that your slope is increase of 2 for a run of 3. That's all it says right there. So it's simply saying that your slope is what value, guys? Simply saying your slope is what?
2.
So I'm going to write that in there. Okay. It says furthermore, the graph, we want to graph this function when g of 0 is equal to what, guys? 2. Well, g of 0 equal to 2 means that's the point 0, 2. This is like the point that we're going to start from. Okay, so how do you get to the point 0, 2? Not down 2, but up 2. Oh, wait a minute, though. Wait a minute. That g of 0 equal 2 is really the point 0, 2, and that 0, 2 falls on which axis? That makes 2 my y-intercept. Okay, I like it. So I've got a starting point for the graph, don't I? In which case, if I start at 0, 2, what can my slope be through that point now? Rise 2, run 3. So let me do that. I shall rise 2. I shall run 3. Rise 2, run 3. Right to here, right, gang? All agree? All agree? Let's see. Let's draw my line. Let's draw my line. I'm going to make this as perfect as I can because we still have to answer for what here, guys? 19, so 19, run 3. As according to my graph, right here, after I've graphed this with a straight edge, and you're going to want to do the same thing with a straight edge. What's it appear my y-intercept is now? I'm sorry, we already knew the y-intercept 2. What's it appear the x-intercept is right down here? Looks like -3. Okay. lot of wordiness in this problem, but again, the idea was to say, hey, finding a starting point, and then from that starting point, do your what? Slope. We had to infer a few things here when I talk about the dependent increases by 2 for every 3 independent change. That's just a really fancy way of saying slope. Okay? Really fancy way of saying slope. Kind of like Donald Trump talking real fancy about how you run a country. If you read between the lines. Yeah, I won't go any further with that because this will turn into an argument. Alright. Okay. This is a great example. Any questions about that? Anybody? Alright, last one here. Let's finish this up today. I like this example. This is a tough one. First thing I'm going to have you do is with a straight edge. If you can do the following for me first. I'm going to kind of put an XY axis up here. But we're really going to be working from the 4th quadrant this time. So you might want to put that up there by your graph. Why don't you label these by a negative 100? So I'm going to count down 1, 2, 3. I'm sorry, 1,000. Okay, I'm going to count by 1,000 for each box, but I'm just going to label every 5,001. Every 5,000. 1, 2, 3, 4, 5. I'm going to label this negative 5,000 right here. Okay. And I think that's what I want to do. Yeah, that'll work. I should call this 5,000. Call this negative 10,000 right here. And then another 5 down, call this negative 15,000. Everybody okay with that? I don't like the way this is going to turn out. But I'm going to make it work. We're going to change the answer. I'm going to make it work. I'm going to make it work. How's that sound?
Sounds good.
Great. What I want you guys to do is this. Each one of these is going to count as 50. Let's go by 2s here for everything. All right, everything's going to go by 2. So I'm going to go 2, 4, 6, 8, 10. The 5th one up here will be a 10. Let's just get this labeled. We'll pick it up tomorrow. Call this 20. 2, 4, 6, 8. Call this 30. Okay. Let's get that labeled right there. And I think I'm going to stop right there. Once you've got that labeled, we'll pick this one up first thing tomorrow. Again, this is going to be a slope-intercept form example. We want to find a start. We want to do a rate of change with this. We'll figure this out here in a second, but should be good.
Carson,
Yeah.
you send Taylor Cox to the office, please?
All right.
Hey, Mr. Parker.
Yeah.
I looked at that